Hello, Spider Peeps. The other day, Big Clive told me, personally, in the way that he does, that the 555 timer was 55 years old. So today, being the 5th of May, here's a special bonus video about 555 timers, which was probably the first integrated circuit that SpiderMaf ever came across back in the day. Before then, he played about with BC108s and BC109 transistors, but then the 555 timer came, and it was in lots of different things back then. The first thing I used it to do was to make a LED flash on and off. And of course, nowadays you can get LEDs that flash on and off themselves. You don't have to do anything with them. And yet, today on Amazon, there was this kit, a 555 kit by RK Electronics. You can still get electronic kits with 555 timers in today, and you would be amazed what still has 555 timers in, even though it's years and years later. That's a beefy boy, isn't it? That's a good one. All right, so this is the 555 timer kit. I'm going to make this now, and while I make it, I'm also going to try and explain how a 555 timer works, and I don't really know. So let's just build this and have a little chat. Okay, so here is a 555 timer, 4 pins on each side, and I've not left enough room for the 4th pin. Some of them are easy. Ground, black wire, VCC, positive wire, voltage in, that's easy. Then this mysterious one is discharge. This one is threshold. What on earth does that mean? This one is control voltage. This is reset. Well, that makes sense. Output, yeah, and then trigger. Okay, reset resets the chip. Output is what sends stuff out to it. Trigger is what makes it do something. What on earth is discharge? What on earth is threshold? Control voltage? Why is control voltage different from that? Let's try and understand these. Okay, so if I get this right, inside we've got like a voltage divider going across those 2 pins. So that's something that we use to sense the voltage. Then we've got a transistor here which turns things on and off. We've got 2 things that I think are like logic gates, but they're actually called comparators. We've got a flip-flop circuit and then an output driver. Obviously the output driver goes to that. Okay, so we've got like a flip-flop there. We've got a output driver there, so that goes into that. One of the flip-flops goes into there. Then we've got a reset, so that reset pin resets this flip-flop. And I think all the flip-flop does is it remembers the last state that it was running, so whether it's on or off, let's say. Here are the 2 comparators. Then we've got some form of resistor voltage divider thing here. I think there's 3 resistors across there. So one goes to there, one goes to there. These 2 are joined. Then those 2 go to the flip-flops. And then one of the triggers goes to one of the flip-flops. A discharge comes to there, yeah, something like that. And a control voltage goes to that. Right, then these are these going like that to the flip-flop, and then something else, a threshold and a control voltage, yeah, somehow go into that. I might have got those pins round. Okay, so let's try and understand that. And this isn't really a very good drawing, is it? Okay, across here, this voltage divider, what this does, that gives us 2 voltages inside the chip. It gives us 1/3 of the voltage that's going into it. So if this was 9 volts going into it, I don't know whether it can take 9 volts. However, this is just my maths. This is 0 volt, that's 9 volts. So 1/3 and 1/3, so that gives about 3 volts there. And that gives about 6 volts. These are sort of like 2 trip wires, these 2 internal voltage. If that internal voltage goes below 1/3, something happens. If it goes above that 2/3, something else happens. Everything else in the chip revolves around comparing those two voltages to those two levels. So this is the voltage that's coming in on the threshold, and that compares your signal via that comparator. Is that over 2/3 of this reference voltage? So if that voltage coming in there is over 2/3, then it goes, all right, that's too high, so turn this switch off. And then the trigger pin says, well, okay, if the voltage coming in here is lower than this 3 or 1/3 of whatever the VCC is, then something is happening, we're being triggered, so turn the switch on. So then this flip-flop, like the memory brain, just remembers whether it's on or off, like a memory bit. So if this trigger comparator gets fired, it turns it to on, and if this threshold turns it to off. Right, I get this. So yeah, if something happens on that pin, this goes on. If something happens on that pin, it goes off. And then obviously the flip-flop controls that output because it goes there. This is an output driver, I think. And then up here, I think there's something else I've missed out. Up here, there's a transistor, discharge transistor. So that's connected to pin 7. This is the discharge. So that transistor, so when the flip-flop's off, that transistor turns on, which makes that pin go to ground. So when I say go to ground, it makes that voltage drop to 0. And then when the flip-flop's on, that transistor turns off, and that doesn't make the voltage go up to 9, but it just doesn't do anything. It's not doing anything. Pin 7's basically saying, do we just drop all the charge to ground now or do nothing, depending on the state of the flip-flop? We can use that maybe for discharging one of the external capacitors. So that might like short the capacitor out and just get rid of the charge that you've built up on it. I think that's why that's called discharge. I don't know. Okay, and reset. So if you pull that low, it forces everything to off. So it makes everything turn to off, which is what I said. So reset, it just makes the chip go back to whatever it was, like an emergency stop button to where it was before. Okay, then control voltage. So what does a control voltage do? If these two voltages are like tripwires, I think what that control voltage does is allows you to move the thresholds about. So when we power that chip up by putting a voltage between the ground and the voltage pins, then it sets two invisible voltages, two tripwires, 1/3 and 2/3 of that main voltage. Okay, so pin 2, the trigger pin, watches for a low input, and if it does, it flips the output to on. Then pin 6 watches for a high output, and if it gets a high output on that, it flips the output to off. And then the flip-flop in the middle of it remembers that state of it, and then pin 7 either dumps that charge to ground when it's in the off state, or it leaves things alone if it's in the on state. I think I've got it. So the 555, I think, is like this voltage referee thing that remembers its previous state. It turns things on when the voltage drops low enough, and it turns things off when the voltage goes high enough. And that uses that transistor inside to either get rid of a charge or lets charges build up. And that's probably why we've always got a capacitor and a resistance in a timer circuit to allow the capacitor to charge up over time. Once that's charged and reached that threshold voltage, then it's discharged by a pin 7, like shorted out, that capacitor goes, or charge goes away, and then we can start again. So I think that's the 555 timer. Have I explained that very well? I don't know, but I think now I understand how it works. It's no longer a mystery. Let's go back to the build. Okay, let's try it again. That's better. So we've got a green light, and then when we trigger it, yay, we've got a red light. It works. And see, so it is a monostable because we've done it once, and now it's changed, and it's just going to stay there until we reset it. There we go. All right, I tell you what wasn't working. They didn't supply all the resistors because some of the resistors are optional, and I'd put R1 in, but that was an optional one, and I should have put R1 in R5 over there. because I think this board can be changed to do different things. But yeah, it works now. So yes, the 555 timer. I didn't even demonstrate a flip-flop. That's terrible, isn't it? I could probably do a flip-flop here somehow just by joining two of these pins together. But yeah, I'll let Big Clive do that. Thanks, Big Clive. Really interesting. And now I understand it a little bit more than I did before. Hope you enjoyed this extra bonus video this week on 555 timer day. Please give me a thumbs up if you like this sort of thing. Bye. It's not really timing, is it? So I think this board has been designed to do loads of different things. We can connect a buzzer to it and it will beep, and there's different resistors in there to do different things. I think these resistors here are for these LEDs. And it looks like we can have an external trigger, and I'm imagining that this is the same as that trigger, but it doesn't seem to be working. Like we said, 555 timer circuits have real good value today. We put the transistor in there as well. That's an output driver for something. I think maybe the buzzer goes on that bit if we had a buzzer. Well, you can see why we're still using this in the 2020s.